Today we're taking a deep dive into the airline fleet assignment problem and illustrating how it works without hesitation, repetition, or deviation starting now. The fleet assignment problem, or FAP, is a complex optimization model used by airlines to assign different types of aircraft to scheduled flights. The goal is to maximize the airline's overall profit by balancing passenger and cargo demand with the available fleet's seating and cargo capacity, all the while minimizing operational costs. The formulation of this problem involves several mathematical elements, decision variables, and constraints which help capture the dynamic nature of airline operations. In the FAP, an airline operates a set of flights between various stations using different types of aircraft fleets. Each flight has a defined origin, destination, and scheduled departure time. The airline can assign these flights to any fleet type where each fleet is defined by its seating capacity, cargo capacity, operational costs, and other attributes like range and noise levels. The decision variable for this problem is binary. This variable takes a value of 1 if a flight is assigned to a fleet type and 0 otherwise. The total number of decision variables is the product of the number of flights and the number of available fleet types. So why do airlines go through all this trouble? Well, the primary objective of the fleet assignment problem is to maximize profit. Profit for each flight depends on the unconstrained revenue and the operational cost for assigning a flight to a fleet type. The net revenue would be the unconstrained revenue minus the operational costs. The unconstrained revenue represents the maximum possible revenue for a flight assuming no seating or cargo capacity restrictions. The operational cost is composed of two parts: the operating costs such as fuel, crew wages, etc., and the spill cost, which represents the revenue lost when an aircraft's capacity cannot meet the total demand for the flight. For example, if a flight has a demand of 200 passengers but is assigned to a plane with only 100 seats, the spill cost reflects the lost revenue from the remaining 100 passengers. The objective is to maximize total profit by summing the profits for all fleet assignments. This is determined by calculating the total net revenue across all possible fleet combinations. The fleet assignment problem includes 4 major constraints to ensure realistic and efficient assignments. In first, we have the coverage constraints. Every flight must be assigned to exactly one fleet type. This constraint ensures that no flight is left uncovered or assigned to more than one fleet. Then we have the resource constraints. These ensure that the number of available aircraft for each fleet type is not exceeded. At any point in the schedule, the number of aircraft in use plus those grounded for maintenance cannot exceed the total number of available aircraft of that type. In third, we consider the through-flight constraints. For this type of connecting flights, the same aircraft must be assigned to both inbound and outbound legs of the journey. This ensures continuity in flight operations. Lastly, we consider the balance constraints. This ensures the number of inbound flights at a station using a specific fleet type must equal the number of outbound flights using the same fleet type. This is crucial for maintaining the flow of aircraft between stations. To illustrate how this works at a very basic level, let's consider a flight between two cities with a demand of 300 passengers and an average fare of $200. The total unconstrained revenue for this flight would be $60,000. If the airline assigns a fleet with 180 seats, 120 passengers cannot be accommodated, resulting in a spill cost of $24,000. If the operational cost for this fleet is $20,000, this would bring the total cost to $44,000, leaving a net revenue of $16,000. At the same time, the airline would have to satisfy all the constraints of the model to ensure maximum profits. The fleet assignment problem defines and formulates the airline's fleet assignment decisions to optimize profitability while ensuring operational feasibility. By taking into account both revenues and costs associated with each fleet assignment, airlines can develop solutions that maximize profits while minimizing operational inefficiencies, all within the constraints of fleet availability, through flights, and flight coverage. If you liked this video, don't forget to hit the like button, leave your thoughts in the comments, and subscribe for more aviation content.